Good morning, friends. Welcome to Water Resources Engineering class. In today's lecture, we discuss on Horton's infiltration curve, measurement of infiltration, measurement of infiltration, measurement of infiltration. So in that Horton's method, I will tell you first. What is that Horton's method? Horton has given an equation for determining actually the infiltration rate. So Ft is what? Infiltration rate at any time t. Suppose you want what is the infiltration rate at any time t. At this time, this is f of t. At any time t, what is the infiltration rate is what we call it as Ft. So he has given an empirical equation for that. What is that? So in that, this is Fc. What is Fc? It is constant infiltration rate. So that means initially the infiltration rate is very high, but after some time it becomes a constant. So this value is what we call it as Fc. This is Fc. Fc means constant rate of infiltration. Constant infiltration rate, or it is steady state infiltration rate is what we call it as Fc. And what is this F0? F0 is initial infiltration rate. That initial infiltration rate is nothing but the infiltration capacity, because the infiltration rate will be very high at the beginning of the storm. So that's why this point is what we call it as F0. This is F0. That means F0 you can call it as maximum infiltration rate, initial infiltration rate, or infiltration capacity at the beginning. Any of these three things are same actually, right? Then Fc constant I mentioned. What is E is nothing but actually it is only natural logarithm I want to take it. What is K actually? K is decay constant actually. K is a decay constant which is always greater than 0. And then T is nothing but time from the start of the rainfall. Once again, see what this curve says. Horton's equation for the infiltration rate is Ft. That means infiltration rate at any time t is equal to constant infiltration rate, steady state infiltration rate plus initial infiltration rate minus constant infiltration rate into e to the power of minus kt. Minus k is nothing but the decay constant. T is time basically from the beginning of the storm. That is what it is. So now this curve is actually a curve wherein the infiltration rate decreases exponentially. The infiltration rate decreases. Infiltration rate decreases exponentially. That is what the Horton's curve is, and he has done it, and he has given an equation, excellent equation which everybody should know it. Remember, infiltration rate at any time Ft is equal to constant infiltration Fc plus F0 minus Fc into e to the power of minus kt. So this completes to me first method. Based on this, we can estimate what is the infiltration capacity. This is the first thing. Suppose for example, if F0 is equal to 15 mm per hour, Fc is equal to 3 mm per hour. What is Fc? Constant infiltration rate. What is F0? Initial infiltration rate. And K is equal to 0.6 and time is 2 hours over the entire period. Then substitute in that, you get the answer. So this is what infiltration rate at any time you can find out using Horton's curve. Please remember, Horton's curve or Horton's method is used to estimate the infiltration rate at any time t. So that is what the first method is. Very important curve that which I have covered here. Then I will go into the conventional methods, which also I call it as the experimental methods actually. These are the experimental methods. Listen carefully when I am talking actually. So in these experimental methods, there are first thing is popular things are ring infiltrometers. Ring infiltrometers are very popular for estimating the infiltration rate. So in those ring infiltrometers, we have two types of ring infiltrometers. Single ring infiltrometers, double ring infiltrometers. Let me take first single ring infiltrometer. Single ring infiltrometer, nothing but it is just a cylinder, a hollow cylinder, a hollow metal cylinder. That's all. This is what I call it as a single ring infiltrometer with some standard dimensions. So that standard dimensions, some people will take it 30 centimeter diameter by 30 centimeter depth, or some people will take 30 centimeter diameter and 60 centimeter depth. So I have taken a ring infiltrometer of 30 centimeter diameter and depth is how much I have taken? 60 centimeters depth. It is just like a cylinder. Bottom is hollow. Please remember, it's only a cylinder. Bottom is hollow. So like that we have taken actually. Then what I have done, now they insert that basically into the ground. Before going for that, first I want to choose an area where I want to measure the infiltration. Normally what we will choose is a flat land we will choose, and similarly there is no vegetation at that place. Such type of place we will choose. Then what I will do, take a ring, the cylinder, that is what we call it as ring infiltrometer. Inside scale is there. So that infiltrometer, take a hammer actually and make it actually what you call it as, put it into the ground. How much we will put it? Almost 50 centimeters of it we make it into the ground. Suppose if it is a hard soil, if you cannot do it, forget about it. You put 30 centimeters. So but that's why I am telling there are different standard sizes of infiltrometers. So this we have taken it actually 60 centimeters. So 50 centimeters we pushed into the ground by using a hammer at the top, hammering at the top, pushed it into the ground. Then how we put it? 10 centimeters is there above the ground. That is first point. Then what we have done? We have taken actually water and pour the water into the ring actually. Into this ring, into this cylinder, we have poured the water and maintained 5 centimeter above the ground level. So that is fixed level. 5 centimeters above the ground level. So that's what we have done, and just we kept quiet. For 10 minutes we kept quiet, for example. Then what will happen? Because of the infiltration, naturally the water level goes down. Then what we have done? We pour again water and make that level as 5 centimeters. Like that we continuously did it for 24 hours. You understand? Long time basically. So if you do that actually, so how much of water you are adding actually to keep this at constant head? So my basic meaning is I want to keep it a constant head. To keep the constant head, how much you are adding the quantity of water is what is more important for us actually. So that is the thing. So now finally how much water you have added divided by the time elapsed actually, during which time you have added, how much is the total time. Then if you put it so much of water basically depth divided by the time, that will give you the infiltration rate. So this is one method. Or there are some other people also talk like this. what they talk. So keep 5 centimeters depth first and then wait for 10 minutes. So whatever that decreases, or wait for 1 hour, whatever the decrease that takes place here, right? Measure that decrease actually. So in this much time, this much decrease has happened. So that is the infiltration rate. So directly infiltration rate they can calculate. So any of these constant head method, variable head method, anything you can choose it, but constant method is something which is preferable. But the only problem with this method is if you observe it, the entire water is not going vertical, because we assume that this entire water has to flow vertically and reach the groundwater table. So what the flow should be only one dimensional. It should be only one dimensional. But what is happening? So you see this naturally this is going out like this. That means this is adding to lateral flow. It is adding to lateral flow. So that is why we should be very careful actually. So if suppose the water is going from here like this, for example, so that means lateral flow. So lateral flow is not considered under infiltration. So that is why this part, whichever is going out, so that is also lost. So we are counting that as infiltration, which is not correct. That is the only difficulty, or that is the only limitation for this particular method. Please remember that. To overcome that difficulty, we have gone for double ring infiltrometer. See the double rings actually. One inner ring is this, outer ring is this. Inner ring diameter is 30 centimeters, outer ring diameter is 60 centimeters. So two concentric rings we have taken. What we have taken? Two concentric cylinders we have taken. There are two concentric cylinders. So suppose inner cylinder is of 30 centimeter dia, whereas outer cylinder is 60 centimeter dia. We have put two cylinders. Now two cylinders, what we have done? We pushed into the ground, and by using a hammer actually. So we pushed it into the ground, but taken enough precaution that there is enough above the ground level. So now in this method also same. Both the cylinders we filled with water. Inner cylinder, outer cylinder. Both we filled with water actually. And we followed the same method whatever we have done in single ring infiltrometer. But our concentration now is on the inner one. Concentration is on inner one, not an outer one at all. Inner one is more important. We maintain constant head in the inner cylinder actually. The outer cylinder purpose is very simple actually, to arrest the what you call it as lateral flow. So outer cylinder will stop that lateral flow. So that is why if you observe this inner cylinder part, most of the water will be going down only. So that is the advantage in this particular thing actually. So see how the double ring infiltrometers are. One is inner cylinder, outer cylinder. They are pushed into the ground. Both are filled with water. So see diameters, inner is 30, outer is 60. 5 centimeters same like actually. So depth is very less because two are there now. To hammer into the ground very difficult. So that's why 15 centimeters inside, 10 centimeters outside we have taken. So now if you observe from the inner cylinder part, if you observe, the entire flow is going vertical. That is what we want. If it is flowing vertical, that is contributing to the infiltration. If it is flowing lateral, actually that is not contributing to the infiltration. It is only flowing as subsurface flow, which is not, we are not calculating that right now. So that's why by using double ring infiltrometer, the outer ring helps to prevent the lateral entry, and the inner ring, the entire water percolates down vertically as a one-dimensional flow downwards. So that is why this method is being used for more accurate for taking up the infiltration rate. Again, the method is simple actually. Only thing is we keep the head as constant. But always principle is both the infiltrometer to maintain head constant, how much water you are adding it, by how much time you are adding it. That basically we take it, the depth of water added divided by the time you have taken is nothing but the intensity, which is called as infiltration rate. So this is a calculation of infiltration rate, a small example. So the volume of water that is added by area of inner ring. Please remember that outer ring has no function except to prevent the lateral flow. The outer ring is only for lateral flow, so that it assists the inner ring, so that the entire flow will be in vertical direction into time interval. If you take it, then naturally volume added, inner ring area, time, then you can get what is infiltration rate. But generally, how much will be the infiltration capacities for different soils if you take it? The very low infiltration capacity means less than 0.25 mm per hour, highly clayey soils. Please note that. Always, because values also we need to have some understanding. If it is less than 2.5 mm per hour, must be a highly clayey soils. Clay in the sense that completely minerals and everything. Then low means actually 2.5 to 25. We call it as infiltration capacity is low. Generally, shallow soils, clayey soils, and soils with organic matter, they are called actually the very low infiltration capacity. Whereas medium is 12.5 to 25. So especially sandy, silt. These are the two for basically medium infiltration rate. High infiltration rate means greater than 25, and this is deep sands and well drained aggregated soils. In such a case, these are the general trend of how the infiltration capacity will be. Then we will go into another experimental method, and this method, previous method infiltrometers, is head constant head. Base principle is constant head is maintained, whereas in the case of rainfall simulator, it is some discharge is applied. This is why it is called as flux method. This method is called as flux method. What do you mean by that flux method? Some certain discharge is applied over the soil. Whether you apply artificially, whether it is obtained by rain, whatever it is. So infiltration rate is measured by using the rainfall simulator. Means something we are simulating, something which we are creating artificially. So rainfall is artificially created over an experimental plot, and then observe the things, then find out what is infiltration rate. That is what we call it as rainfall simulator method. So a rainfall simulator is a device that artificially produces rainfall over a specific area with a controlled intensity and duration. Once we say it is only artificially producing rainfall, means intensity is in our control, duration is also in our control actually. Mainly actually for the sake of research purpose, to estimate the infiltration rate in a particular soil, we use such type of methods. Prepare the soil plot, that is the first thing. Install the simulator. What is that simulator? It gives rainfall actually at the desired intensity for a desired duration. Then start simulated rainfall actually. So that means we keep the simulator in such a way that up, for example, at a 2 meters height we keep it, and the rainfall occurs like just raindrops, it occurs actually with an intensity of 20 or 40 mm per hour. Like that we will do it. So what we will do throughout the time duration, we maintain rainfall intensity as constant. That is first thing again. Then what we will do, so when once the rainfall intensity, whatever we are applying is known, what is the volume of rainfall, we know it. So when once the volume of rainfall, we know it, what is the volume of water flowing on the surface of the soil, that we will measure. That is what we call it as runoff. We measure it. So volume of water applied is known to us because we only simulated the rainfall. So what is the runoff, basically surface flow that is flowing, we calculated. Then we take the initial and final soil moisture conditions also. Then if based on that, what is infiltration rate? Rainfall rate minus runoff rate. Whatever is the rainfall rate minus runoff is equal to, suppose if you take it, this is the plot, right? This is the rainfall which we are making it. This is the rainfall, basically rainfall rate, and this is runoff rate, and whatever is going down actually is nothing but the infiltration rate. So that is how it is mentioned. Repeat the test for number of times so that you will get actually accurately the infiltration rate. There are certain advantages because controlled conditions, we can repeat the experiment number of times, and especially for research it will be very, very useful. But only thing is it has some limitations also, because whatever simulated rainfall may differ from the actual rainfall, the actual raindrop size and energy of water, and edge effects are also, because you are taking small plots, the edge effect also will play an important role, and naturally equipment cost is high. These are the things. So with this background, we will go into the last actually, how you can really find out the infiltration rate using infiltration indices. Before going to infiltration indices, so what we have done till today, first we observed what is infiltration, we defined what is infiltration rate, what is the infiltration capacity we defined. Then after defining these three terms, how to measure, what are the factors affecting infiltration, we studied. Once the factors are completed, then we have gone for measurement. So in the measurement there are two mentions. One is the measurement, the other one is estimation. So first thing is estimation by an empirical method, Horton's curve we explained. Then afterwards the conventional methods, experimental methods like single ring infiltrometer, double ring infiltrometer also we explained. Then after that the rainfall simulator also we have taken. So these are the things which we have taken. Then what do we mean by infiltration indices and how they are going to be useful? So this completes to me. Thank you so much.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.